Okay, this is to help with 9.5, day 2, number 12. We have to evaluate the sum. And so basically we want to know this would actually be terms starting 2 up to 10. If we added all those terms up, what would the sum be? So currently, to me, this is decently hard to understand. So what I often do is just make a little table of the actual value. So like here we start with n2, 3, 4, 5, 6, up to 10. Okay, and I could certainly list them all out and add them up. That would be one way to do it. It's just gets to be a lot of work. So I'm just going to do the first couple to see if I can make some sense of it. So when n is 2, I just plug it in and do 1/2 times 2, which is 1 plus 3. And then for 3, it's going to be 1/2 times 3 plus 3. So this would be 1.5 plus 3, 4.5. Okay, and I already start to see the pattern, right? This is actually sort of a slope of 1/2. So not surprisingly, it's going to go up by 1/2. But if we're not sure about that yet, we can put in a 4 for n, and half of 4 is 2, add 3 is 5, right? But certainly at this point, I can start to see what the pattern is, and I could just extend it out, okay? And then for the 10th term, right? Oh, actually, I think we are going to need the 10th term. And the reason is, right, we have to add all these up. All right, so this is going to be an arithmetic pattern because we're going up by 0.5. So the formula for that is the arithmetic pattern is the number of terms divided by 2, and then the first term plus the last term. Okay, so again, if you need help with those formulas, formula sheet. Right, we have an arithmetic sequence. We're trying to find the sum. It's a finite series. Sorry, it's a series, I guess, not a sequence. And it's finite because it ends at the 10th term. Okay, so one of the tricky parts is how many terms do we actually have? So it seems like there would be 8. If you do 10 minus 2, there'd be 8. But if you actually count it out, there's actually 9 terms here. So you have to do 10 minus 2 plus 1. There's actually 9 terms we're summing. Okay, the other tricky part about this is a sub 1 normally stands for the first term, which you might think, well, now I need to go back and do n of 1 and get this value, but it's actually the first term in our sum. So the first term in our sum is actually just this 4. Okay, and then the last term is going to be the 10th term. So I need to figure out what is the value of the 10th term. So I'm going to put in 10 for n. Half of 10 is 5, plus 3 is 8. Right, so that tells me that my last term is 8, the 10th term. Okay, and now I just crunched the formula and I ran out of space here. But it would be 9 divided by 2, 4.5 times 12. So 4 12s is 48, plus half of 12 is 6. And add those together, so it should be a sum 54. And again, that makes sense if you think about it. If you add these numbers up, it'd probably be about 54. So the sum of that um, series in summation notation is 54. All right, hope that helps.